looking at 2.3, which is, where's my pen going? Oh, here it is. Deductive reasoning. So in 2.1, we looked at inductive reasoning. And then in 2.2, we focused on counterexamples. Now we're going to move into deductive reasoning. So the difference in deductive versus inductive reasoning. Okay, so deductive reasoning is the process of using facts, rule, definitions, and properties to reach a logical conclusion. So when we talk about using logic, we're talking about deductive reasoning. Okay, again, you are using facts, rules, definitions, and properties for deductive reasoning. Okay, it is your logical thinking. Okay, you come to a logical conclusion based on facts, rules, definitions, and properties. Inductive reasoning, what we did with like pattern recognition, you were using examples or observations to make a conjecture, right? So that's the difference. It's using observations or examples, recognizing patterns. That's inductive reasoning. Deductive is based in logic, based on facts, rules, definitions, etc. Does that make sense? Kind of, sort of? Okay, we're going to look at a couple of types of deductive reasoning. Okay, we're going to apply a couple of laws of deductive reasoning. And then y'all's practice today, you're going to do some logic puzzles. Okay, we're going to talk about how to reason through, and then you're going to apply that with some logic puzzles. So first of all, a conditional statement is simply a statement that's written in if-then form. Okay, if-then form. Who used to read if you give a mouse a cookie, or if you give a moose a muffin, or what are some of the other ones?
Well,
yeah, but most people have read one of those books. They kept, if you give a pancake, if you give a pig a pancake, if you give a moose a muffin, if you give a mouse a cookie, if you've never read one of those books, they're children's books that are full of conditional statements, if-then statements. Because, y'all, stop talking, please. Okay? The original story, if you give a mouse a cookie, starts out, if you give a mouse a cookie, then he's going to want a glass of milk to go with it. That is a conditional statement, an if-then statement. Okay? That book is just a sequence of conditional statements. Okay? So that's kind of what we're going to talk about today. So what conditional statements, just an if-then statement, if-then form of a statement. Okay? The law of detachment, which is one of the forms of deductive reasoning, tells us that you can draw conclusions from a true conditional and a true statement P. So a conditional, the symbolism we use for conditional statements, let me get my highlighter here. When we talk about a conditional statement, an if-then statement, this is the symbolism we use. We would read that as if P, then Q. Okay, so the P is what comes after the if, the Q is what comes after the then. So if you give a mouse a cookie, then he's going to want a glass of milk. You give a mouse a cookie is the P, he's going to want a glass of milk is the Q. Does that make sense? Well, it doesn't stand for anything. It is the hypothesis of the conditional, and the Q is the conclusion of the conditional. So that's what this is saying down here. Let me underline. So we'll do the P of your conditional. That is called the hypothesis. Okay. So when we say if P, P is the hypothesis, then Q, Q is the conclusion. So if you're told an if P then Q statement is true, and then that P is also true in whatever the situation is, then logically, doesn't it make sense that Q must be true? Yes? Okay. I know a lot of y'all, when we talk about this law of detachment, people are like, isn't this just common sense? And I mean, for most people it is, but it does have a name. It's called the law of detachment. It's a form of logical thinking. Okay. It's the process of understanding if I have this true conditional statement and the hypothesis is true, then the conclusion must also be true. Okay. In other words, okay, whatever your general conditional is that's true, that's your given statement. Okay. If we apply it to a specific situation and we're told that the conditional's hypothesis is applied, then it makes sense. Okay. We can draw the conclusion that the ending, the Q, must also be true. Are we okay so far? I think maybe it'll make more sense when we do an example, if this is kind of confusing you still. Okay, so in this example, in these multiple examples, we're going to be given a conditional statement. So I'm going to color code green and blue. I'm gonna do the hypothesis and the conclusion. Okay, and then after the conditional, they're going to tell us something that's happening. And we have to decide, based on that information, can we draw a conclusion using law of detachment? If we can, we're going to write the conclusion. If we can't, we're going to say no valid conclusion. Okay. So again, the color coding may help. If you can't color code, if you don't have colors, I do have colored pencils and highlighters and stuff you're welcome to borrow. But maybe it would be better if you did like circling versus underlining if you only have one color. So I'll do that. I will underline the hypothesis and I will circle the conclusion. Okay, I'll do it that way in case you have one color. All right, so in number 1, it says, if Helen is going to work, then she is wearing pearls. So Helen is going to work is my P. She is wearing pearls is my Q. So that's my if P then Q statement. Now, after that given statement, they say, okay, Helen is wearing pearls. Can you draw a conclusion based on that? Is that Helen is wearing pearls, the P or the Q of the conditional? That's the Q, right? Okay, so let's go back up here to law of detachment and read it one more time. It says, okay, if your P and then Q is true and P is true, then Q must be true. That's drawing your conclusion. Did they just tell us P right here? Helen is wearing pearls. That's P. That's Q. So they didn't say that the hypothesis is true. They went straight to the conclusion, right? So in this one, I cannot draw a valid conclusion. Now, that doesn't mean that that she's not going to work. It means that it's not a guarantee. It means that there could be another reason she's wearing pearls, right? Where might she be going in her pearls? Maybe she's going on a date, you know? Maybe she's going to a wedding. I don't know. But I can't draw a guaranteed valid, so I would say no valid conclusion. Okay, and if you want to put a reason, she could be going on a date or whatever you want to say. Some other reason she might be wearing pearls. Okay, so this was Q that they told us after the conditional. So if it's not P, then I can't conclude Q. Okay. Number 2, if a pet is a rabbit, okay, so a pet is a rabbit is P, then it eats carrots. That's Q. So that's the conditional statements. If a pet is a rabbit, then it eats carrots. Jenny's pet eats carrots. Is that Q or P that they're applying here? They're telling us Q. So I can't go backward to P. So no valid conclusion can be drawn. What's another pet that maybe eats carrots? A pig, a hamster. Okay, so her pet could be some other animal besides a rabbit that eats carrots. Okay, let's try 3. If a hen is a Plymouth Rock, then her eggs are brown. Okay, Plymouth Rock is a type of hen, if you didn't know that. Okay. Berta is a Plymouth Rock. Is that the P or the Q? The Plymouth Rock, that was Q, wasn't it? I'm sorry, I underlined it in the right color and I said the wrong letter. That's P. So can I conclude Q? So I can conclude since they told me Berta's a Plymouth Rock, I can make a valid conclusion that Berta's eggs are brown. Okay, so if that second piece of it, if the piece of information that they give us after the conditional is your hypothesis, you can draw the conclusion. Does that make sense? It's starting to make a little more sense the more we do. Let's try another one. If a road is icy, okay, so a road is icy is my P. Then the driving conditions are hazardous. That's my Q. They just told us the driving conditions are hazardous. Is that P or Q? That's Q. Can I go backward to draw a conclusion? No. Okay, it's if P, then Q. If P, then Q. If P, then Q. It's not Q, then P. So I cannot do a valid conclusion here. What's another reason the driving conditions may be hazardous?
Rain.
Maybe there's rain, maybe there's fog, maybe there's an accident, maybe a truck tipped over and spilled something. There's lots of hazardous driving conditions that are not ice. I'm just going to pick one to use for the example. Okay, do we feel okay about law of detachment? Okay, that's law of detachment. All right, guys, I need the side conversations to stop. The quicker we get through this, the more time you have to practice. Okay, so law of syllogism. This is another form of deductive reasoning. Okay, law of syllogism allows us to draw conclusions from 2 true conditional statements. So if we have 2 conditional statements and the conclusion of the first one is the hypothesis of the next one, then we essentially can cut out the middleman is what's happening here. So I'm going to try and color code this again. So if we have if P, then Q, and we know that that's true, and then we're also told if Q, then R, doesn't it make sense that I could go straight knowing if P is true, then R is going to be true? Okay, so you're cutting out the Q, the repeat in the middle. You're going straight from P to R. Okay, in other words, if you have multiple connecting if-then statements, you can take the first if, first hypothesis, and the last then, and write a conclusion. It's like condensing your information. Okay, you're shortening it up. If we're talking about the book, if you give it, does anybody remember how it actually ends at the very end of If You Give a Mouse a Cookie? What does he end up wanting at the end?
Another cookie? I don't know.
I don't remember what it is.
I read that book.
But essentially what law of syllogism says, since every page of that book connects, Like it starts out, if you give a mouse a cookie, then he's going to want a glass of milk. And then the next page is, if you give him a glass of milk, then he's going to want, I don't know, a straw. If you write, it just keeps going. And it's like the end of the first page is the beginning of the next page. That's law of syllogism. They're saying, well, let's just take the first page and the last page and condense it, shorten up that story. That's law of syllogism. Okay. So in this example, we're given, if you wake up on time, then you do not miss your bus. If you do not miss your bus, then you are not late for school. So I have a repeat here of the you do not miss your bus, don't I? So I can cut out that middleman and just take the P and go straight to the R. So I would write this. If you wake up on time, then you are not late for school. Very good. These are your notes. No, you're not turning them in. Okay. So I took my P, went straight to my R. Okay. So in terms of the symbolism, what I'm going from if P, then Q, if that's true, and if Q, then R is true, therefore, that 3 dots in a triangle like that, when you see that, that means therefore. If P, then R must also be true. Okay, so if seeing it in symbolism helps you, write that out in symbols. That's what we're doing. We're cutting out the middleman, the repeat Q in the middle. So far, so good? Okay. All right. Y'all look, I'm going to number the tables. I'm going to tell you which one I want you to try. So Vincent, y'all are table 1. Y'all do number 6. Try number 6. Okay. Carter, y'all are table 2. Y'all try 7. Ian, y'all are table 3. Y'all try 8. Okay. Let's see. Addison, y'all try 9. Y'all's group, do number 9 on your examples. Marin, y'all's table, we'll go backward. Y'all do 8. Let's see, Benny, y'all do 7. Okay, and then Owen, y'all's table, y'all do 6. Okay, so just try one of these. Condense it. If P then Q, if Q then R, therefore if P then R. Okay, condense your scenario.
Can you scroll up?
Huh? Oh, up here? Yeah. All right, I'm going to put attendance in while everybody, y'all talk to your table, make sure y'all all got the same thing.
Is a whole unit just like what's the point of that?
No, we're learning about logic and different types of reasoning skills because then we're going to apply them to do proofs where we, like mathematical proofs, where we prove problems, prove things. Given this piece of information, can I prove this? And you use logical. Because we just want to take everybody's word for stuff. Anything anybody says is true, or do they need to prove that's true?
Well, I mean, the machine.
Just let the machines run the world. I'm not saying you're going to use it in what you choose to do for a career. You will use logical thinking in everyday life. So
No, but already know it.
okay, great. Then this should be an easy unit. everybody think they have theirs? Yes? Anybody need more time? Give you about, I'll come back to y'all's group then. Let's start with another group. And I'm gonna type instead of handwrite here, just so it goes a little faster. Okay, what group, let's see. So, watch your language, please. All right. Landon, what did y'all say for number 6? What did y'all condense it to? Guys, I need y'all to stop talking. I'm asking one person a question. That's the only person that should be talking. Perfect. Okay. So if and you can write this. If this isn't the one you did, go ahead and fill it out now. Okay. I'll color code this. Okay, but this is the conclusion that we can draw from that. Okay, so our P, if an angle is supplementary to an obtuse angle, and then we ended with R, that's the conclusion of the second statement, its measure is less than 90. So we were able to cut out that repeat of acute. Does that make sense? Okay. All right. Let's see. Which group? Julian, what did y'all say for 7? Did y'all do 7? What'd y'all say? Jalen, do you have it, or Carter? Something, I don't care. Somebody. Yes, if the measure of angle A is less than 90, then angle A, I'll write that out. I'm going to leave space for the angle symbol. That's in symbols. I'll just write that. So if the measure of angle A is less than 90, then angle A is congruent to angle B. Very good. Okay. All right. Who did? Nathaniel, did y'all do number 8?
Yeah.
What did y'all say?
Texting class.
All right, so that one was a little different. What was different about that one? There was more than 2 statements, but they all connected, didn't they? Okay, so law of syllogism still applies even if it's more than 2. Okay, so it said if you're texting, then your phone gets taken away. If your phone gets taken away, your mom gets mad. If your mom gets mad, then you get grounded. So we can cut out all the middle stuff and just say, if you're texting in class, you're going to get grounded. The end. Make sense? Okay, Addison, was it y'all's group that did 9? Okay, just somebody there? I don't care. Maggie, anybody who wants to say what y'all put? Guys, I couldn't hear because other people were talking. Can you say it one more time? Okay, so if we go to the park, was that the very first hypothesis? If it's nice outside. So we'll start with the first hypothesis. So if it is nice outside, then our last, make sure everything connected, then we'll go to the park. We go to the park, we'll take my dog. If I take my dog, I'll need to bring a bowl of water. So then I will need to bring a bowl of water for the dog. Yeah.
You need to bring a bowl of water. Say for my dog.
It doesn't hurt to add that, but it's not necessary. This be all we needed. All right, so I'm just going to color code these for our notes. So we're starting with the very first P. You didn't get all those, I'll post this and you can get them all copied down. We cut out all the middlemen and just get the very last conclusion. All right, do we feel okay about law of syllogism and law of detachment? Okay, so we're going to use deductive reasoning skills. We're going to use facts and rules and things that are given to us as true statements, as facts, to draw conclusions, okay, by doing some logic puzzles. Now, before I pass out the logic puzzles, here's what it looks like. Okay, so there are 5 of these logic puzzles that you're going to have, but I'm not going to make this due until Friday. So you've got all week to do these logic puzzles. Some of y'all probably do them faster than others, and that's okay. I'm going to give you the whole week. Okay, this is going to be due Friday. But what I need you to do while I'm passing this out is I need you to get your Alex set up. Okay, so everybody needs to get out their laptops and go to the SSO portal.